Okay, so welcome to all of you. So today we will see how to find the error. Okay, so now error means what? So suppose x is a quantity, so that we want to compute. Okay, so that means what? Suppose x is the exact value of the quantity and x1 is its approximate value. X1 is its approximate value. Okay, so I take it. The error is nothing but the true value, that means x is the true value of that quantity and x1 is the apparent value of that quantity. Then you have to find an error of this. Error is nothing but what? The true value minus the approximate value. That is the error. Okay. So now what do you mean by absolute error? Just you have to take the modulus of that one. You will get the absolute error. Absolute error, it is denoted by EX and it is nothing but a mod of real value minus approximate value. Okay. That means true value minus approximate value. Then relative error is what? The absolute value, that means absolute error upon the exact value, magnitude of the exact value, that is the true value. Okay, so that is what? Relative error. Okay, then percentage error means what? So percentage of the relative error, so you have to just multiply by that 100 to the relative error, so that is mod of x minus x1 upon x into 100. That is these are the formulas to find the relative error, percentage error, absolute error, and error, right? So note that is. Note that delta x we have taken the number such way that mod of x minus x. Then delta x is called the absolute accuracy. It's called absolute. That means if x is rounded to n decimal places, then your absolute accuracy, that means this is delta x is 1/2 into 10 raised to minus n. So if you want to find accuracy, absolute accuracy, then this is the formula to find it. So what is here? So you want to find the value of the capital N, right? So how many rounded? So x is rounded to decimal places. So these decimal places, so you should know. Okay. So these are the formulas, right? So we'll see the problems on it now. Okay. We'll solve the problems on it. So only you have to remember this 4 formulae: error, the approximate, absolute accuracy, and so on. So we'll see some problems on it. Okay. So example. If x is equal to 0.25 and x1 is equal to 0.251, is correct. To 2 decimal places, then find the absolute error, and absolute accuracy, delta x. Solution: your exact value is 0.25, your x1 is 0.251. Okay, now what you have to find? You have to find absolute error now. Absolute error. So 0.25 minus 0.251. So now here the use of the scientific calculator is allowed. So if you can't find this, so with the help of the scientific calculator you can find this one. So easily you will see this number is bigger. So I can subtract this number from this one. So we get this is modulus of, or you may write this is minus 25001 now here. 001. This is what? 0.001. Right? Subtract the biggest value from subtract the lowest value from the biggest number. So this one 0 to 5 is the biggest number from as compared to this one. So subtract this 0.25 from this one. So you get this. So and this is actually negative. So this will what? You have to make this as a positive, right? Because absolute value. Then you have to write the absolute accuracy. Absolute accuracy. So if x is rounded off two decimal places, so therefore the absolute accuracy is what? 1 upon 2 10 raised to minus 2 into 10 raised to minus 2. This is the formula. So this is what? 1 half means 0.5 upon this is 100. Then this is what? 0.059, right? 0.005. 10 raised to minus 2, this becomes 100. 1 upon 1 half is nothing but 0.5. So we can write this instead of writing 1 upon 200, and then you buy with the help of the calculator, you can do this one, or you can write 1 upon 200 as it is. Okay. So but what here? So write any number in the numerical form, like this one, decimal form, right? You would write 2 upon 5, 2 upon 7 in the whole of the course. Okay. So write in the decimal place, in the decimal form. Okay. So every number write in the decimal, every answer write in the decimal form, right? So now we take the next problem. Now if x is, next problem, if x is 0.51 and is correct to two decimal places, then find the absolute error delta x and percentage accuracy. Okay, solution. X is equal to 0.51 is correct to two decimal places. Therefore, delta x is equal to 1 half into 10 raised to minus 2. Correct up to 3 decimal places, then 10 raised to minus 3. So this is 0.5 upon 100. So this is what? 0.5. Okay. Now we have to find the percentage accuracy. Percentage accuracy means delta x upon mod x, actually upon x. Delta x upon mod x. You have to take the positive value. So this is what then? 0.05 upon 0.51. Into 100. Percentage you have to take. So into 100 into 100. So with the help of the calculator, you have to find the value of this one. With the help. So it may be 98 now. Maybe 98. Okay. So we use the calculator and find the value of that one. Okay. So I don't have the calculator. Just I am doing this is what? 98. Check whether your answer is correct or not. Okay. Now we take the next problem. If x is, next problem, if x equal to 0.1416 and is correct to 4 decimal places, then find the absolute Then find absolute accuracy. Find absolute accuracy. Delta x and percentage accuracy and percentage accuracy. Okay, solution. X is equal to 0.1416 is correct to 4 decimal places. So therefore absolute accuracy is equal to delta x is equal to 1/2 10 raised to minus 4. So this is 0.5 upon 10 raised to 4 now here. So this is what 0.40. Okay. Then percentage accuracy is equal to delta x upon mod x into 100. So this is what 0.12345 upon 0.1416 into 100. Okay. So whatever this answer, so do take a calculator. The scientific calculator allow. Just type like this. 0.0005 into 100 divided by 0.1416. Okay, just type. So no need actually in the bracket. So bracket facility is also given in the scientific calculator. Okay, so that also you can do this. Other you can do this one divided by this into 50. Okay. So but use the bracket for this one. Just what divided by, just write this first divide, write and this value and then multiply this. Write as a bracket now here. What? Bracket. So first the open bracket. So this one divided by this one. Close the bracket into 100. Do like this. So whatever the answer for me, just I am writing this one 0.35%. Just check whether it is correct. This is 0.035 is the answer I have calculated. Okay, so this is the answer I have calculated. But check for whether this is correct or not. So do your own now here. Okay. Now we'll take the next problem. If x is equal to 3.1416 and x1 is equal to 3.14159, it's correct to 5 decimal places. Then find the absolute error. Absolute error and absolute accuracy is different. And absolute accuracy. Then find absolute error, absolute accuracy. Okay, solution. X is equal to 3146 and x1 is equal to 3.14159. Okay, absolute error is equal to mod of x minus x1. So mod of x, so 3.1416 minus 3.14159. Okay, so use the calculator and find the value of this one. Just I will write directly the value. This is what, just from this and this minus. So this is what actually the minus, because this number. So which number is bigger? This number is bigger now. So no problem for this one. Okay. So this is what, point 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So this will be same as what? 0, 0, 0, 1. Okay. So 5 units. Okay. So this is absolute error. Now we have to find absolute accuracy. Now x is equal to 3.1416 is correct. Is correct up to, is correct to 5 decimal places. 5 decimal places. 5 decimal places. Okay, is correct to 5 decimal places. So therefore what? Delta x 1/2 into 10 raised to minus 5. So this is 0.5. 10 raised to 5 means there are 5 0. There are 5 0. So this is what then? 0.1, 2, 3, 4, 5. Okay. Absolute, only absolute accuracy, not a percentage. If you want percentage accuracy, then you have to divide by x and multiply by 100 again. Okay. So I hope that you understand this, how to find the absolute error and absolute accuracy. Okay. So absolute accuracy is different now. Okay. So relative error, you can also find the relative if x and x1 is given, then find the relative error, percentage error, and so on. Okay. So do the problem for the relative error and the percentage error for this one. Okay. So next we'll take the problem. Let x is equal to, let x is equal to, okay, let x is equal to 3.1416 be the actual value of x, value will be the value of the number, value of the number and x1 is equal to 3.14159 be the approximate value of the number pi, suppose. Find, see the problem, find error, relative error. Now here we are covering all the formulae now here. Relative, percentage error. Okay, so here we are covering all the formulae. Okay, solution. Given that x is equal to 3.1416, x1 is equal to 3.14159. Okay, so now first we will find error. Error is what? X minus x1, whatever this. Okay, maybe positive, maybe negative. So 3.1416 minus 3.14159 is equal to 0.12345. Okay, so this is 1. Okay, next what you want? You want relative error. Okay, relative error. What is the formula for relative error? Relative error is nothing but mod of x minus x1 upon mod x. This is the relative. That means you have to find approximate error. No need to find the absolute error now here, because you have already got error. Just take the magnitude of that one. So this is what? 0.00001 upon x. X is what? 3.1416. Just I am writing this value. So you have the calculator. With the help of calculator, just write the value of this one. This is what? 0.1123450. 1, 2, 3, 4, 5, 0. then 831. Okay, so this is the value. So now see how many digits are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So your calculator should be more than 12 or more than 12 digits. Then this will give the correct value. Otherwise, what you have to find a 1 upon this one, and then just manage this your 5 points then. Okay. Then what you want then? Percentage error. Percentage error. Don't write this symbol. This is what then relative error into 100. So just multiply by 100. Then this is what. Just I writing the formula and directly write the answer, because you have already calculated the relative error. Just multiply by the 100 to the relative error. You get the value. Just if you multiply by 100, this 20 will. Just you have to drop that 20 only. This is what then A1. So there are what? How many zeros are there? So there should be the 5 zeros only. So there should be the 5 zeros. Okay. So 2 zeros are drop. You have to drop the 2 zero. Then this is what 31831. This will be your answer. Okay. So do with the help of the calculator. Scientific calculator is allowed for you. So use that one. Okay. Now we'll take the next problem. Find relative error and percentage error of the number 8.6 if both of digits are correct to both are correct. Okay, solution. X is equal to 8.6 is correct to two decimal places. Then absolute error is equal to 1/2 into 10 raised to minus 2. So this is 0.5 upon 100, 0.005. Okay. Relative error. So this is what absolute error upon this x. So this is what 0.005 upon 8.6 So that will be here mod x you have to take the 0.58. I don't have calculator, therefore I am using this book here. So just writing this whatever the value calculated as before. So just I am writing this. You do your own. So check whether this is correct or not. Okay. Now next one, what you want? Find relative error and percentage error you want. Okay. Percentage error. So this is what then. So 10 into 100 into relative error. So just multiply by 100. So you have to drop these two. This will what then? 0.58 now. 0.58. Okay. So this is the 0.58 percentage. Is your percentage error now. Next, evaluate the sum √3 s is equal to √3 plus √5 plus √7 to 4 digits, to 4 significant digits, 4 significant. This word is very important now here. Significant. For significant digits and find its absolute error and relative error. Now this is the problem. So what here? Root 2, root 3, root 5. You have to find the value of this one with the help of scientific calculator. Okay. Solution. S is equal to root 3 plus root 5 plus root 7. So I will take use the calculator, and you have to take the 4 significant digit. You have to take the 4 significant digit from the calculator. Just write the root 3 from the calculator. Just see the screen and take only the first 4 digits now. The first 4 digit is what? 1.732 plus. Then root 5. Find the root 5. Just see the screen on the calculator and just take the per 4 significant digit. So this is 2.236 plus 10 root 7. So take first 4 significant digit, that is 2.646, and this value take its sum, that is 6.614. So this is your S. This is your S. Okay. Now you have to find absolute error. Absolute error. For this one, so it is what? 4 significant digit. That means what? 10 raised to minus 4. 10 raised to minus 4. Plus for this one, again this is what? 10 raised to minus 4. 1/2 into 10 raised to minus 4. Right? So this is 0.5 plus 0.5 plus 0.5 is what? 0.15. This is what? See, this you can write. This is what? 0.5 upon 140. Okay. So 40 here. Plus 0.5 upon 40. Plus 0.5 upon 40. So this is what? 0.15 now. 0.5 plus 0.5, 50 upon 40. So this is what? 0.00015. Okay. So then your absolute error now. These are the absolute error. This is correct up to 3 decimal places. So now here what? It should be 3 now. This is 3 now. So this is not 0.15 actually. This is 1.5. This is 1.5. And so this is what? 1.5. So this is what? 0. Okay. So this is 3 now. Because what here? 3 decimal places. Right? So this is 3 decimal places. So you get the absolute error. Okay, so absolute error. So relative error is same as what? absolute error upon mod x. Right? So now here what? So this is the absolute error. So that means you have to take the value s is like this 6.61 only. Yeah, this is the approximate value. Correct to the 3 decimal places because these are corrected, right? So the exact value is what? So absolute error, just subtract this one. This will what then 6.61 now. So this is what then 0.0015 upon 6.61 is equal to what then 0.002. What you want only absolute and relative error. So you got a relative error. So question in the question there is no percentage error. Okay, whether class relative error only, not a percentage error. So this problem is over here. Okay, so I hope that you understand this one. So error, this is the error now. How to find the error? Like this. Note that for this one, correct to this one. This is the exact value of this. This one correct to 3 decimal places now here. Significant 4 significant correct to 3 decimal places there. So that means your value is what you have. We are taking exact value at 6.61 now. Okay. So I hope that you understand this one. So now we'll stop here.